18, three business partners, Kosgei, Kimani, and Atieno, contributed 1,750,000 towards an investment. Kosgei contributed 20% of the money. Kimani and Atieno contributed the remainder in the ratio 3 to 5 respectively. Part A1, calculate the amount of money Kimani contributed. We've been told that they jointly contributed 1,750,000. Kosgei contributed 20% of the money, and Kimani and Atieno contributed in the ratio of 3 to 5 the remainder of the money. So from this information, we can conclude that Kimani and Atieno's percentage contribution is the total, which is 100%, minus Kosgei's percentage contribution, which was 20%. So their percentage contribution was 80%. So in terms of cash, it is 80 over 100 times the total contribution, which is equals to 1,400,000. Then Kimani and Atieno contributed in the ratio 3 to 5, and we need to find Kimani's portion. So we shall use Kimani's portion, which is 3, and over the total ratio, which is 3 plus 5 times 1.4 million. So it is 3 over 8 times 1.4 million, and therefore Kimani's contribution was 525,000. Part A2, find the ratio of the contributions by the three partners. So from part A1, we obtained that Kimani's contribution was 525,000. And so we can obtain Atieno's contribution by subtracting Kimani's contribution from their joint contribution. And we obtain these figures in part A1 as well. So it's 1,400,000 minus 525,000, which is 875,000. Then Kosgei contributed 20% of the total. So it's 20 over 100 times 1.75 million. And the figure is 350,000. So the ratios of contribution for Kosgei, Kimani to Atieno is 350,000 to 525,000 to 875,000. Then we simplify this. We can start by dividing the ratios by 1,000. We have 350 to 525 to 875. If we divide by 5, we have 70, 105, 175. Divide by 5 again, we have 14, 21, 35. Then divide by 7, we are left with 2 to 3 to 5. So the ratios of contribution of Kosgei to Kimani to Atieno is 2 to 3 to 5. Part B, the money earned a compound interest at the rate of 8% per annum. After 3 years, the partners withdrew the interest and donated 10% to a charitable organization. The partners then shared the remainder in the ratio of their contributions. Calculate the amount to the nearest shilling that each partner received. So from the narrative, we've been told that the money was compounded at the rate of 8% per annum for 3 years, and they withdrew the interest and donated 10% to a charitable organization, and they shared the remainder in the ratio of their contributions. So in relation to calculating compound interest, we can use the formula A is equals to P into 1 plus R over N raised to NT, where A is the total amount after compounding, P is the principal, R is the interest rate per year, N is the number of times compounded per year, and T is the number of years. So when we substitute, we have 1,750,000, which is the principal, into 1 plus, the rate is 8% per annum, so it's 0.08 over 1, because the compounding happens once a year, then times 1 times 3, because we are dealing with 3 years. This simplified is 1,750,000 into 1.08 raised to power 3, which is equals to 2,204,496. So this was the total amount that they would have obtained after 3 years, but they only withdrew the interest. So to obtain the interest, we subtract the principal from that amount. We have 2,204,496 minus 1,750,000, and we obtain 454,496. But 10% was donated to a charitable organization. So the percentage that remained for them to share was 100 minus 10%, which is 90%. So the amount that was shared was 90 over 100 times the compound interest amount, and it's equals to 409,046 shillings and 40 cents. And from part A2, we obtained that the ratio of their sharing was Kosgei to Kimani to Atieno 2 to 3 to 5. So using these ratios, we shall compute the amount that everyone obtained. We have for Kosgei, it's 2 over the total ratio, which is 2 plus 3 plus 5 times the amount shared, and this is equals to 81,809 and 28 cents. But we have been asked to give the answer to the nearest shilling, so this is approximately 81,809. Then for Kimani, it's 3 over 2 plus 3 plus 5 times the shared amount, which is equals to 122,713 and 92 cents. And it's approximately 122,714 shillings. And for Atieno, 5 over 2 plus 3 plus 5 times the shared amount, which is 204,523 and 20 cents. And it's approximately 204,523. So those are the respective amounts that each partner obtained. Question 18. A solid consists of a conical part, a cylindrical part, and a hemispherical part. All parts have the same diameter of 12 centimeters. The height of the cylindrical part is 15 centimeters, and the slanting height of the conical part is 10 centimeters. Take pi is equals to 3.142. Calculate part A, height of the solid. So using an illustration, that is the solid, the top is the hemispherical part, then we have the cylindrical part at the center and the conical part at the bottom. And we need to find the height of the solid, which is the total of the H1, H2, H3. We have denoted the diameter as D and the slanting height of the conical part as L. And the dimensions are D is equals to 12 centimeters. The height of the cylindrical part, which we have denoted as H2, is 15 centimeters. And L, the slanting height of the conical part, is 10 centimeters. So we start by obtaining the height of the conical part, the hemispherical part. And its height is the same as the radius of the hemisphere, and the radius is a half the diameter. So to obtain H1, it's a half of the diameter, which is 12 centimeters, and so H1 is equals to 6 centimeters. Then for H3, we are going to use the Pythagoras theorem, since it forms a right angle at the center of D, where we have denoted D. So we have H3 squared will be L squared minus R squared. We substitute, we have H3 squared is 10 squared minus 6 squared, which is equals to 64. So H3 is the square root of 64, and therefore it is equals to 8 centimeters. So the height of the solid is H1 plus H2 plus H3, which is 6 plus 15 plus 8, and therefore it is 29 centimeters. Part B. Calculate the surface area of the solid correct to 1 decimal place. That was the illustration of the solid, and the diameter is 12 centimeters. The height of the cylindrical part is 15 centimeters, and the slanting height of the conical part is 10 centimeters. Then in part A, we established that the radius is 6 centimeters. The H1 is 6 centimeters and H3 is 8 centimeters. That is the height of the spherical part and the height of the conical part. So we are supposed to find the surface area of the solid, and to find the surface area of the solid, we need to find the surface area of the various parts. So starting with the hemispherical part, we are going to compute the surface area of the curved part, which is 2 pi r squared. We substitute, we have 2 times 3.142 times 6 squared, which is 226.224 square centimeters. Then we compute the surface area of the cylindrical part. That as well is the curved surface, the area of the curved surface, which is 2 pi r h, and in our case the h is the h2. So we have 2 times 3.142 times 6 times 15, which is 565.56 square centimeters. Then we have the surface area of the conical part, the curved part as well, which is pi rl, and that is 3.142 times 6 times 10. We have 188.52 square centimeters. So the area of the solid is a summation of the various surface areas, which is 226.224 plus 565.56 plus 188.52, and that totals up to 980.304, and correct to 1 decimal place, it becomes approximately 980.3 square centimeters. Part C. Calculate the volume of the solid correct to 1 decimal place. The dimensions of the solid that were given are: the diameter is 12 centimeters, the height of the cylindrical part is 15 centimeters, and the slant height of the conical part is 10 centimeters. In part A, we computed and obtained the radius of the common radius is 6 centimeters, the height of the hemispherical part is 6 centimeters, and the height of the conical part is 8 centimeters. So to compute the volume of the solid, we need to compute the respective volumes of the different parts, and then we sum them up. So the volume of the hemispherical part is 2 over 3 by r cubed. We substitute, we have 2 over 3 by 3.142 by 6 cubed, which is 452.448 cubed centimeters. Then the volume of the cylindrical part is pi r squared h, and our h is h2. We have 3.142 by 6 squared by 15, which is 1696.68 cubed centimeters. Then the volume of the conical part is a third pi r squared h, and in this case h is h3. So we have a third times 3.142 times 6 squared times 8, which is 301.632. So the volume of the solid is the summation of the volumes of the various parts, which is 452.448 plus 1696.68 plus 301.632, and the total is 2450.76. To 1 decimal place, it is approximately 2450.76 cubed centimeters. Question 19. The average speed of a pickup was 20 kilometers per hour faster than the average speed of a lorry. The pickup took 45 minutes less than the lorry to cover a distance of 180 kilometers. If the speed of the lorry was x kilometers per hour, Write expressions in terms of x for the time taken by the lorry and the pickup respectively to cover the distance of 180 kilometers. So the pickup was 20 kilometers per hour faster than the lorry, and it took 45 minutes less, and the speed of the lorry was x kilometers per hour, and the distance covered was 180 kilometers. So we need to express the time taken as an expression of x. So to obtain time, you need to divide distance by the speed. So for the lorry, it is 180, which is the distance over x, the speed. So the lorry took 180 over x hours. Then the pickup, the distance was 180, and the speed, if the speed of the lorry was x and the pickup was 20 kilometers per hour faster, the speed was x plus 20. So the time taken by the pickup was 180 over x plus 20 hours. Question 19, part A2. Determine the speed of the lorry and that of the pickup. So using the same information that we had been given, we have the pickup speed was 20 kilometers per hour faster than the lorry, and it took 45 minutes less. Then the speed of the lorry was x kilometers per hour. The distance traveled was 180 kilometers. And in part A1, we obtained that the time taken by the lorry was 180 over x, and that of the pickup was 180 over x plus 20. So the first step is to convert the difference in time into hours. So we convert the 45 minutes into hours, and 60 minutes is 1 hour. So we obtain the value of 45 minutes, which is 3 over 4 hours. So that means the time taken by the pickup plus 3 over 4 is equal to the time taken by the lorry. Then we simplify this, we find the LCM of the equation on the left hand side. We have the LCM of the two is 4 into x plus 20. Then x plus 20 goes into 4 into x plus 20 4 times, then times 180, and 4 goes into 4 into x plus 20, 3 x plus 20 times, then you multiply by 3 is equals to 180 over x. We open the brackets, we have 720 plus 3x plus 60 over 4x plus 80 is equals to 180 over x. We put the like terms together, we have 3x plus 780 is equals to 3x plus 780 over 4x plus 80 is equals to 180 over x. Then we cross multiply. We have x into 3x plus 780 is equals to 180 into 4x plus 80. Open the brackets, we have 3x squared plus 780x is equals to 720x plus 14,400. Then we form a simultaneous equation by moving all the terms to the left hand side of the equation. So we start by subtracting 720x on both sides of the equation. We have 3x squared plus 60x is equals to 14,400. Then we also do the same for the 14,400. So our equation is 3x squared plus 60x minus 14,400 is equals to 0. We can simplify this further by dividing both sides by 3. So we have x squared plus 20x minus 4,800 is equals to 0. Then to solve the equation, we can use the factorization method, and the factors of negative 4,800, whose summation is 20, is 80 and negative 60. So we have x squared plus 80x minus 60x minus 4,800 is equals to 0. Then we factor out the common factors in pairs. We have x into x plus 80 minus 60 into x plus 80 is equals to 0. So that means x minus 60 into x plus 8 is equals to 0. And so we have x minus 60 is equals to 0, or x plus 8 is equals to 0. We find the value of x. So x is equals to 60, or x is equals to negative 80. And since we are dealing with speed, speed cannot be negative. So that implies that x is equals to 60. And we were asked to find the speed of the lorry and the pickup. So the speed of the lorry, which is equals to x, is 60 kilometers per hour. And the speed of the pickup was x plus 20. So it is 60 plus 20, which is equals to 80 kilometers per hour. Part B, the distance between towns A and B is 240 kilometers. On a certain day, the pickup started from town A at 8:30 a.m. and the lorry started from town B at the same time. Determine the time that the lorry and the pickup met. So we have the pickup starting from town A and the lorry starting from town B. The total distance between A and B is 40 kilometers and they both started at 8:30 a.m. From part A2, the speed of the lorry is 60 kilometers per hour and the speed of the pickup is 80 kilometers per hour. So we are going to let the time taken before the two meet equals to y, and we know that distance is equals to speed times time. So the distance traveled by the pickup is the speed, which is 80, times y, which is the time taken, and that is 80y, and the distance traveled by the lorry is 60 times y, which is equals to 60y. Since they are moving in opposite directions, it means that at the time of meeting, they both have together they have covered a speed of a distance of 240 kilometers. So 80y plus 60y is equals to 240. We find the value of y, which is 140y is equals to 240. Divide both sides by 140. Y is 12/7 hours. We convert these hours to hours and minutes. It is approximately 1 hour 43 minutes. And they started at 8:30 a.m. So the time they met was 8:30 plus 1 hour 43 minutes, which is equals to 10:13 a.m. So the two met at 10:13 a.m. Question 20. A forest is enclosed by 4 straight boundaries A, B, B, C, C, D, and D, A. Point B is 25 kilometers on a bearing of 315 degrees from A. C is directly south of B on a bearing of 260 degrees from A. And D is 30 kilometers on a bearing of 210 degrees from C. Part A, using a scale of 1 to 500,000, represent the above information on a scale drawing. We shall start off with a rough sketch. We've been told that point B is 25 kilometers on a bearing of 315 degrees from A. So assuming this is our point A, B is 315 kilometers from A. So this is 315 degrees. That is point B. And it's 25 kilometers away. Then C is directly south of B on a bearing of 260 degrees from A. So assuming that is the north, C is directly south and it is 260 degrees from A. So we shall measure 260 degrees roughly there. So where the two will intersect, that is our point C, and BC is a boundary, so this will be a solid line. Then we have D is 30 kilometers on a bearing of 210 degrees from C. Thirty kilometers away. So that is D, and it is 30 kilometers. Then AD is a boundary as well, so we shall join A to D. So this is just a rough sketch of what we need to plot, and the scale is 1 to 500,000. So these are centimeters. We convert them to meters. It becomes 1 centimeter represents 5,000 meters. Then convert them to kilometers, divide by 1,000. We have 1 centimeter rep 5 kilometers. So we start off. We shall mark that as our point A. Then, since the protractor can only measure 180 degrees, and we need to measure 315 degrees, we can either subtract 315 from 360 degrees and measure in the anti-clockwise direction. It's 5, 4. So we need to measure 45 degrees anti-clockwise from point A. And then it is 25 kilometers, and since 1 centimeter represents 5 kilometers, so this should be 5 kilometers. So that is point B. Then we have C is directly south of B. So we need to plot and it is 260 degrees from A. So we can subtract 260 degrees minus 180. It is 80 degrees. So 80 degrees in the second half. So where they intersect, that is our point C. Then, so we can make the extension of BC dotted just for visibility. Can make that line dotted. Then from is 25 kilometers. Then we have D is 30 kilometers on a bearing of 210 from C. So 210 minus 180, we have 30 degrees. And it is 30 kilometers from C. So 30 kilometers, we have 1 centimeter represents 5 kilometers. So 30 will be 6 centimeters. So that is D. And then you join A to D. You can delete this extension for clear visibility. Then you join A to D. So there you have the scale drawing. This is 30 kilometers. Part B1. Using the scale drawing, determine the distance in kilometers of D from A. We will measure DA. It is 9 centimeters. So DA is 9 centimeters. And remember, the scale was 1 centimeter represent 5 kilometers, sorry. So 9 centimeters. We need to find what 9 centimeters represent. We'll cross multiply. It's 9 by 5 over 1, which is equals to 45 kilometers. Part B2, using the scale drawing, determine the bearing of A from D. We need to find the bearing of A from D. So we start by plotting a true north at point D. You can use a set square. So that is the north. Then we measure the angle to point A. According to my diagram, it is 48 degrees. The bearing is 48 degrees. The bearing of A from D is 48 degrees. Part C. Calculate the area correct to 1 decimal place of the forest in square kilometers. This is the drawing that we've done to scale. Then we are supposed to find the area of the forest, which basically is the figure ABCD. So to find the area, we can subdivide the figure into two parts, where we have triangle ABC and triangle ACD. So the area of the forest will be the area of triangle ABC plus the area of triangle ACD. And whenever you have a triangle and you know at least two sides and an angle, you can use the sine formula to find the area of a triangle, which is a half times the first side times the second side and sine of the angle between the two sides. So applying this, the area of triangle ABC will be a half times length AB times length BC and the sine of angle ABC. So we have a half times AB is 25 kilometers, BC is 4.2 centimeters in the drawing, then we multiply times 5 due to the scale, because 1 centimeter represents 5 kilometers, and then sine 46 degrees, angle ABC is 46 degrees based on the scale drawing that we have. So that gives us the area of triangle ABC as 188.8267 squared kilometers. Then the area of triangle ACB is a half times CD times DA, the sine of angle CDA, which is a half times CD is 30 kilometers, DA we've measured, and we obtained 45 kilometers, and then angle CDA is 18 degrees. So that is 208.5865 squared kilometers. So the area of the forest is the summation of the two, which is equals to 397.4132, and to 1 decimal place is 397.4 squared kilometers. These figures may vary based on your scale drawing. So you might have the scale drawing that have slightly different figures. That is due to your accuracy in the drawing. So once you do the scale drawing, the numbers may vary slightly, but ideally this is how you go about doing the problem. Question 21. The position vectors of points A and B are OA is equals to 2, 4 and OB is equals to 12, negative 4. A point M is on AB such that AM is equals to a half AB, and a point N is on OB such that ON to NB is equals to 1 to 3. Part A, find AB. Part A1, find AB. So using this as an illustration, we've been told that OA is 2, 4, OB is 12, negative 4, AM is a half AB, and ON to NB is 1 to 3, and we are supposed to find AB. So using the illustration, to get to AB, you need to move AO, then OB. and AO is the reverse of OA. Therefore, AB can also be said to be negative OA plus OB. Then negative OA is 2, 4 plus OB is 12, negative 4. We open the bracket, we have negative 2, negative 4 plus 12, negative 4. We sum the two, we have negative 2 plus 12 and negative 4 plus negative 4. So AB is 10, negative 8. Part A2, find NM. So we have an improved illustration based on the information that we have been given. And from part A1, we obtained that AB is equals to 10, negative 8. So we need to find NM, and based on the illustration, NM is NB plus BM. And since we have been given we have obtained AB, which is 10, negative 8, it means BM can be written as negative MB. So NM is NB minus negative MB. We have ON to NB is 1 to 3. So that means NB is 3 over 4, the total ratio of OB, and MB, since AM is a half AB, it means MB is a half AB as well. So that means NM is 3 over 4 OB minus a half AB. We substitute, we have 3 over 4 into 12, negative 4, minus 1 over 2 of 10, negative 8. We open the brackets, we have 3 over 4 times 12, 3 over 4 times negative 4, minus a half times 10 and a half times negative 8. So that is 9, negative 3 minus 5, negative 4. We combine the two, we have 9 minus 5 and negative 3 minus negative 4. So NM is 4, 1. Part A3, find the magnitude of NM correct to 1 decimal place. We already have this information, and NM, vector NM is equals to 4, 1. So we need to find the magnitude of NM, and finding the magnitude of a vector is similar to computing the hypotenuse of a right-angled triangle. So NM, the magnitude of NM is equals to 4 squared plus 1 squared, then we find the square root of the summation, which is the same as the root of 17 is equals to 4.1231, and to 1 decimal place is approximately 4.1. Part B, a translation vector maps A onto A prime, 5, negative 1. Find the coordinates of the image of B under the translation vector. So we have the information that a translation vector mapped A onto A prime whose coordinates are 5, negative 1. And we need to find the coordinates of B under the same translation vector. So from the coordinates we've been given of A prime, it means that the vector OA prime is 5, negative 1. Then we shall let the translation vector equals T. And so to get T, you move from AO through OA prime. And since we have OA, we can express this as negative OA plus OA prime. We substitute, we have negative 2, 4 plus 5, negative 1. We open the brackets, we have negative 2, negative 4 plus 5, negative 1, which is equals to negative 2 plus 5 and negative 4 plus negative 1. This is equals to 3, negative 5. So T, which is our translation vector, is 3, negative 5. And now we need to use this T to find the coordinates of the image of B. So for illustration purposes, we need to find OB prime, and then we use the OB prime to find the coordinates of B prime. So OB prime will be OB plus T. OB is 12 negative 4 and T is 3 negative 5. So we sum the two. We have 12 plus 3 and negative 4 plus negative 5, which is equals to 15 negative 9. So if OB prime is 15 negative 9, this implies that the coordinates of B are 15 negative 9. Question 22. The number of students in 40 schools in a certain sub-county were recorded as follows. You have the numbers. Part A, complete the frequency distribution table below for the data. So we are supposed to use the data we've been given to complete the table. So having this as the data, we need to fill in the table, and ideally we just need to tally the respective number of schools that have the number of students as grouped in the table. So for the schools that have students between 100 and 199 are 4, between 200 and 249 are 6, 250 to 399 12, 400 to 599 10, 600 to 799 6, and 800 to 849 2 schools. Part B. On the grid provided, draw a histogram to represent the data. On the grid, we have the frequency density and the number of students. So since we don't have frequency density in the table we computed in part A, we need to compute the frequency density. So we're going to plot the same table. It had the number of students grouped, we have the number of schools, so for the students they were grouped as follows: 100 to 199. We have 200 to 249, 250 to 399, 400 to 599, 600 to 799, and 800 to 849. Then we tallied the number of schools as follows. This was 4, 6, 12, 10, 6, and 2. So the first thing we need to find is the class width for the various groups of students. And to find the class width, you take the upper limit of the class minus the lower limit of the class. So for example, in this case, it's 199.5 minus 99.5, which is 100. Then 249.5 minus 199.5, 50. 399.5 minus 249.5, 150. 599.5 minus 399.5 is 200. 799.5 minus 599.5 is 200 as well. And 849 minus 799.5 is 50. So using the class width and the frequency, which is the number of schools, we can find the frequency density. Whereby you divide the frequency, in our case the frequency is the number of schools, divided by the class width. So 4 divided by 100 is 0.04. 6 divided by 50, 0.12. 12 divided by 150, 0.08. 10 divided by 20, 0.05. 6 divided by 200, 0.03. And 2 divided by 50, 0.04. So we have the frequency density, so we can plot our histogram. So the first class is, the lower limit is 99.5 and the upper limit is 199.5. So it's between these two spots, and the frequency density is 0.04. So this will be the height of the bar. Then we have 199.5 to 249.5, and 249.5 is the central point between 199.5 and 299.5. So it's up to this point. We need 0.12. Then we have 0.08 for 249.5 to 399.5. 0.08. Then we have between 399.5 to 599.5, it's 0.05. Then we have 599.5 to 799.5, 0.03. And lastly, 799.5 to 849.5 is 0.04. Then now we form the bars. So there we have our histogram.
Part C1. Use the histogram to estimate the median.
The median is the middle value, and if you have the frequency as an even number, to find the median, it is the nth over 2 value. So in our case, since the total frequency is 40, that is the total number of schools, our median value is the 40 over 2 number. So it is the 20th number. And the 20th number, using the number of schools, will be in the class 250 to 399, because we have 4 plus 6, that is 10, plus 12, it is 22. So it means the 20th value is in this class. So our median value is in the class 250 to 399. And to find the exact location, we have said that the frequency before the median bar is a total of 10, which is 4 plus 6. And therefore, the part of the frequency that is on the left-hand side will be, so the median is the 1 over 2 by 40, which is the 20th value. So at median bar, it is the 20 minus 10, which is the 10th value. In the class of 250 to 399, and we have, in that class, we have a total of 12 values. So we need to divide the bar of 250 to 399. On one side, it will be 10 values, and on the other side, it will be 2 values. So that means if you divide this bar by 12, we have it should be somewhere here. So that is the median axis. And the frequency, f on this side is 10, and the f on this side is 2. So to find the value of the class width for the 10 values, since we have the frequency and the frequency density is 0.08, so the width of f equals 10 will be 10 over the frequency density of that class, which is 0.08. So that is equals to 125. So that means between this point up to the axis, this width here is 125. So the median value will be 125 plus, now the value from the start to that point, And if this is 199.5 and this is 299.5, the midpoint of the two will be 249.5. So 125 plus 249.5, giving us the median as 374.5. So the median is 374.5.
Part C2. Use the histogram to estimate the number of schools with more than 350 students.
We need to estimate the number of schools with more than 350 students, and 350 is at this point. So this is the point where we have 350 students. We need to find the frequency from this point up to the last bar. And since the 350 lies in the class 250 to 399, and we know the class width is 150, and the 350 is like at a third of the bar, it means the class width between this point to this point is 50. So we can use the width of 50. So the width is 50. It means from the 350 students axis to the end of that bar, this is 50. And we have the frequency density as 0.08. So to find the frequency, we shall multiply the width, which is 50, times the frequency density, which is 0.08. And this gives us 4. So the frequency in the first bar, in the bar where we start having more than 350 students, is 4. So the number of schools with more than 350 will be the first frequency, which is 4, plus the frequencies of the other bars. We have 10 plus 6 plus 2, and so the total is 22. So it means there are 22 schools with 350 students and more.
Question 23a. Given that matrix M is equals to 3 P minus a half P1 is a singular matrix, find the value of P. We have matrix M is 3 P minus a half P and 1. It is a singular matrix and we need to find the value of P. So for a singular matrix, its determinant is equals to 0. So supposing we have a matrix X which is equals to ABCD, the determinant, which is AD minus BC, is equals to 0. So going back to our matrix M, the determinant will be 3 times 1 minus P minus a half times P is equals to 0. If we open the brackets, we have 3 minus P squared minus a half P is equals to 0. Open the brackets further, we have 3 minus P squared plus a half P is equals to 0. We can write this as negative P squared plus a half P plus 3 is equals to 0. This is a simultaneous equation, but since we have a fraction in one of the coefficients, we can multiply both sides by a factor that will eliminate the fraction. So in our case, we shall multiply the equation by negative 2 to eliminate the negative coefficient of P squared and to eliminate the fraction in the coefficient of P. So we have 2P squared minus P is minus 6 is equals to 0. Then we can solve the simultaneous equation using factorization. So the factors of negative 12, whose summation is negative 1, is negative 4 and 3. And that gives us 2p squared minus 4p plus 3p minus 6 is equals to 0. The common factors between 2p squared and 4p is 2p, so 2p into p minus 2, then 3 into p minus 2 is equals to 0. So 2p plus 3 into p minus 2 is equals to 0. That means 2p plus 3 is equals to 0, or p minus 2 is equals to 0. So 2p plus 3 minus 3 is equals to 0 minus 3, and p minus 2 plus 2 is equals to 0 plus 2. So 2p is equals to negative 3, or p is equals to 2. We simplify the 2p to find the value of p. So p is equals to negative a half, or p is equals to 2. Part B. Kirai earned a basic salary of X Kenya shillings per month and Y Kenya shillings for each extra hour worked. Mutua's basic salary is 20% more than Kirai's basic salary, but also earns Y Kenya shillings for each extra hour worked. In a certain month, Kirai worked 30 extra hours and earned a total of 70,000 Kenya shillings, while Mutua worked an extra 40 hours and earned a total of 88,000 Kenya shillings. Part 1. Form two equations in X and Y to represent Kirai's and Mutua's total earnings. So for Kirai, the basic salary was X Kenya shillings per month, and he earned Y Kenya shillings for each extra hour. In 1 month, he worked 30 extra hours and the total salary was 70,000. Then for Mutua, the basic salary was 20% more than Kirai's. Each extra hour was Y shillings. He worked an extra of 40 hours and earned 88,000 in that month. So to form the equations, for Kirai, we need to add the basic salary plus the amount paid for the extra hours, which is X plus 30 times Y is equals to 70,000. Therefore, X plus 30Y is equals to 70,000. That is the equation to represent Kirai's total earnings. Then for Mutua, his basic salary was 20% more than Kirai's. So it will be 120% of X plus he worked a total an extra hours, 40 extra hours times the rate, which is Y, is equals to 88,000. We solve that, we have 1.2x plus 40y is equals to 88,000. So that is the equation for Mutua's total earnings. Part 2. Use matrix method to solve for x and y. So the equations were x plus 30y is equals to 70,000 and 1.2x plus 40y is equals to 88,000. So to use the matrix method, we need to factor out the coefficients of the unknown and group them into one matrix. So we have 130, 1.240, then times xy is equals to 70,000, 88,000. So the coefficient matrix, we can label it as A, the variable matrix as X, and the resultant matrix as B. We know that A times X is equals to B. So to find X, we need to multiply A by its inverse in order to form an identity matrix. So the inverse of A, multiply on both sides. On the left hand side, we are left with X. So X is equal to the inverse of A times B. And to find the inverse of A, it is equals to 1 over the determinant of A times the adjoint of A. So supposing you have a matrix D with the values A, B, C, D, the determinant is AD minus BC, and the adjoint is D minus B minus CA. So going back to our matrices, we have A is 131.240. So the determinant of A will be 1 times 40 minus 30 times 1.2, which is equals to 40 minus 36, and it's equals to 4. Then the adjoint of A will be 40, 1, negative 30, 40, negative 30, negative 1.21. So the inverse of A will be 1 over 4 into 40, negative 30, negative 1.21. We open the brackets, we have 1 over 4 times 40, 1 over 4 times negative 30, 1 over 4 times negative 1.2, and 1 over 4 times 1. So the inverse of A is 10, negative 15, 2, negative 0.3, 1 over 4. So going back, we need to find X, which is the inverse of A times B. We substitute, then we multiply. We have 10 times 70,000 plus negative 15 over 2 times 88,000 and negative 0.3 times 70,000 plus 1 over 4 times 88,000, which is equals to 40,000 and 1,000. So this implies that the value of X is 40,000 and the value of Y is 1,000. Question 24. The displacement S meters of a moving particle after t seconds is given by S is equals to 2 over 3 t cubed minus 7 over 2 t squared minus 6t plus 8. Determine the velocity of the particle when t is equals to 5. We have the displacement function S is equals to 2 over 3 t cubed minus 7 over 2 t squared minus 6t plus 8, and we need to determine the velocity when t is equals to 5. So given the displacement function, we need to first find the velocity function, and to find the velocity function, we need to differentiate the displacement function in relation to the time. And to differentiate, you multiply the coefficient of the variable times its power, and then you subtract the power by 1. So this will be 3 times 2 over 3, which is 2. Then 3 minus 1 is squared, so 2t squared minus 7 over 2 times 2 is 7. 2 minus 1 is 1, so 7t, and then minus 6t implies it's 6t raised to power 1, so 1 times 6 is 6, then t raised to 1 minus 1 becomes t raised to 0, which is 1. So that gives us the velocity function as 2t squared minus 7t minus 6. Then we need to find the velocity when t is equals to 5, so we need to substitute t by 5. So we have 2 into 5 squared minus 7 into 5 minus 6, which is equals to 50 minus 35 minus 6, giving us 9 meters per second. So the velocity when t is equals to 5 is 9 meters per second. Part B, determine the time t seconds when the particle is momentarily at rest. So remember the anchor equation is S is equals to 2 over 3 t cubed minus 7 over 2 t squared minus 6t plus 8. And in part A, we obtained the velocity function as 2t squared minus 7t minus 6. So we need to find the time, t seconds, when the particle is momentarily at rest. And at rest, the velocity, since the particle is not moving, velocity is equals to 0. So that means our velocity function will be equated to 0. So 2t squared minus 7t minus 6 is equals to 0, forming a quadratic equation. And since we can't solve it by factorization, we need to use the quadratic formula. And if you have a quadratic equation ax squared plus bx plus c is equals to 0, the formula to obtain x is minus b plus or minus the root of b squared minus 4ac over 2a. So going back to computing the value of t, it will be minus negative 7, because our b is negative 7, plus or minus the root of negative 7 squared minus 4 times a, which is 2, times c, which is negative 6, over 2 times a, which is 2. So this gives us 7 plus or minus the root of 49 minus negative 48 over 4, which is 7 plus or minus root 97 over 4. So t is 4.2122 or negative 0.7122. But since we are dealing with time and time cannot be negative, it means that our t is 4.2122 seconds. Part C. Determine displacement S meters when the particle is momentarily at rest. This is the displacement function. We obtained the velocity function, and at rest t was 4.2122 seconds. So we need to find the displacement, and to do that we are going to substitute t by the value we have obtained. So it is 2 over 3 into 4.2122 cubed minus 7 over 2 into 4.2122 squared minus 6 into 4.2122 plus 8, which is equals to negative 29.5487 meters. Part D. Determine acceleration of the particle when t is equals to 4 seconds. We have the displacement function and the velocity function, and we need to find the acceleration when t is equals to 4 seconds. So the first step is to find the acceleration function, and to obtain the acceleration function you need to differentiate the velocity function in relation to time. So the acceleration function will be 2 times 2, which is the coefficient of t, times the power of t, which is 4t, and then the power minus 1 remains 4t, minus 7 times 1, which is 7, then t raised to power 1 minus 1, it becomes t raised to 0. So it is 4t minus 7. The acceleration function is 4t minus 7. Then we need to find the acceleration when t is equals to 4. So we substitute t by 4, which is 4 into 4 minus 7 becomes 16 minus 7, which is equals to 9 meters per second squared. So if you want to learn more about integration and differentiation, we have a video named Integration and Differentiation, so make sure you check it out.